we continue. So today we're looking at isomerism under alkenes. So we defined an isomer. To say an isomer is a compound that has the same molecular formula but different structural formula. So example. Now maybe before we look at an example, alkenes has two isomers. Alkenes has two isomers. Number one, we have what you call positioned isomer. And number two, we have what we call branched. So branched isomers. Alright, so from here, let us look at one example. So look at hexene. So hexene, so number 6. So say 1, 2, 3, 4, 5, 6. Okay, I'll just put my double bond here. Hope you watched the previous video. The reason why I have only 2 hydrogen here and 1 hydrogen here. If you didn't watch, search for it. There, you will find it. So this is hexene. This is hexene. Now to write the isomers, we'll look at the first isomer as positioned. Look at positioned isomer. Okay. So under positioned isomer, so a positioned isomer, which we are going to show here. So from what we have been given here, to write a positioned isomer is just to shift the position of the double bond. To write a positioned isomer, it's just to shift the position of the double bond. So say, okay, so one, 2, 3, 4, 5, 6. So the double bond is on, it is on carbon number 1. So I'll just shift it here. Or let me shift it somewhere. Let me put it 1, 2, 3. Okay, let me put it here. So once I shift this one, this double bond, it means that I have done my positioned isomer. So what is remaining now is to put the hydrogen. So you see that here the double bond was here. I had only 2 hydrogens. Now since I have 1 carbon, a single bond here. So since I have a single bond, then these 2 carbons are not affected. So they are going to have 4 number of hydrogen they deserve. Then these, they are affected. So it will be something like this. So this is my positioned isomer. So to write the name now, we will number the number of carbons starting from a carbon which is closer to the double bond. Meaning, I can't start from here to say 1 from here because this carbon is far from the double bond, but this carbon is nearer to the double bond. So by numbering, I will say 1, 2, then 3, 4, 5, 6. Whenever you are numbering the carbons, make sure that the first carbon, the carbon are going to give, are going to consider to become number 1, must be closer to the double bond. So after we do this, the importance of doing this is to write a name now. So for me to write a name, I know that this one is hexane. So to write the name of the isomer, now the alkenes, they have 6 letters. So we have 3. Okay. So for me to write the name now, I'll follow this pattern. So I'll say hexane, then hyphen, carbon, the double bond is on carbon number what? So 1, 2. Then I'll put 2 hyphen like this. So this is the name. So the essence of writing this number is to indicate where the double bond is located. In case I've been given this name, then they say draw the structure for this isomer. This number is guiding you where to put the double bond. So that is how you write the names. Then B, will look at a branched isomer. A branched isomer. So a branched isomer will follow the same one which we have. Now I'm just going to give it a branch. So I will say 1, 2, 3, 4, 5. Whenever you are given a branch, if it is one branch, meaning the numbers of carbon in a straight line or a straight chain. So these numbers, these carbons, you're going to remove one carbon from the straight chain, so that that carbon are going to remove it to form a branch. So I'll put my branch here. We talked about the name of this branch. Then I'll maintain the same position 1, 2. So I'll maintain it like that. So then we write the way it's supposed to be. So 1 carbon, 1 carbon, 1 hydrogen, not carbon. All right, so if you look at this, so we have this branch. The name of this branch, remember, we said the name of this branch is called the methyl. It's a methyl. It's a methyl. So to write a name from this information which we have here, we are going to add another information. So to write the name of this isomer, we'll say the first thing, write the parent name. So the parent name is found by, or is being identified by counting the number of carbons in a straight chain. So we have 1, 2, 3, 4, 5. So because of a double bond, we know that the parent name now is pentene. That's a parent name. Then we need to add something. So in terms of numbering this, we know that we have 1, 2, 3, 4, 5. The reason why we have started from here, we said D, because this carbon is closer to the double bond. So to write the full name, to write the name now, we need to, since we know the methyl group and the position where it is being held, so we'll say 4 methyl. Then the parent name is pentene. Then pent hyphen, the double bond is on carbon number 2 hyphen, then you put ENE. So that is the full name. So these 4, not this. Let me write it properly here. It's supposed to be 4 methyl, then pentane. So um, what we are saying now is that pentane. What we are saying now is that this 4 is representing the carbon where the branch is holding. Then this 2 here is representing the double bond where the double bond is located. So when they give you this, when they give you this name, they mean this diagram. So that is how we write the isomers and alkenes. Thank you for watching.